Good morning, everybody. Hopefully everybody's doing well on this Wednesday. And thanks for joining in on the September free webinar. Got a few people probably going to be joining in as we get this started here. Had a lot of signups today and just kind of waiting for them to come in, but we'll get started here. This month we are going to be talking about true position, probably all of your favorite thing to measure on your microview. With the tolerancing, the basics, any material conditions that you have on it. There's a lot that goes into true position. So we're going to cover a lot of that today. And I want to thank a bunch of customers that sent me parts to do real life examples. A lot of them I am not able to show their blueprints, but I will describe and show you the tolerances the best I can to go over those features. So let's get started. I wanted to do a quick August webinar review. We've been doing these webinars since late March. I've been getting a lot of good feedback saying that it's been helping a lot of people out, just little things in each webinar that they didn't know about. That improves their programming process, makes their measurements easier to take. So last month we kind of, I like to say it's like almost like a potluck of different topics that we talked about. We talked about streamlining your programs, having a skeleton program of all the constants that you have. So every program, if you're typing in your operator initials, part numbers, lot numbers, all those kind of things, is just having a skeleton program to start every program that you do off, so you're not having to do a bunch of text and prompts every single time. We talked about file paths, being organized, where your data is exporting to, where your programs are saved, where your master programs are saved. And we talked about sharing programs. So if your customer or supplier has a microview as well, or other facilities that your company might have, you guys can share programs between the two. We talked about getting your semi-automated programs up and running as quick as possible, and I'll show you a couple of those examples today when I'm doing true position. Even if the first measurements that you take to set up your first system isn't your datum structure, at least your semi-automated program gets up and running quicker. So I'll kind of show a couple examples as I'm doing that today. And then we just talked about vision or touch probe first. Yeah, just a couple different things here. One thing that I wanted to talk about was a couple topics came out of last month's webinar of these skeleton programs. There was a customer that just taking manual measurements, so any quick measurements, not writing a program, but every single time they went into inspect, they had to go in and change where their serial port and their exports were going to. And that's not necessarily something that you could have a global change that every single time that you open up inspect has certain defaults. It has a lot of defaults that you can set, so every time it opens up, but there's a few that don't allow that. So we actually explored an option to creating a manual export program that every single time, instead of opening up the inspect software, you open up this program. So the example was they had in tools, they were having to go to playback options every single time, go to export serial port after run confirm, and then find their serial port that they were sending to their data collection software. So instead of having to do that every single time just to take a manual measurement on maybe one diameter and move on, if you configure all this information and then save it, so we're going to do that. I'll pretend that I set up my serial port, and let's say that we want to send it to an Excel file on our desktop here of manual exports .xls. Remember, you always got to type in .xls if you want it to go to an Excel file. Save, and then if we just save this as a manual measurement program, every time you open up that manual measurement program, you have your export already set up and you have your serial port already set up. So you don't have to do that every single time. Also, another thing that came up is that one customer they had wanted 5 decimal places. One customer they had wanted 3 decimal places for inches. So they would have to go into new program defaults and a couple other things to change the decimal places every single time. But if you save a program of just 3 decimal places and a program of just 5 decimal places, whatever it might be, then you don't have to go and change that every single time. So just kind of little tricks there that instead of having to do more work than you have to every single time. Just wanted to throw that out there. But let's get into true position, what everybody's here for today. What is true position? How do we measure it? How are we tolerancing it? And how do we export it? I say this every single month that we're on the webinar. Make sure to join the chat. And any questions that you have, go ahead and pop them into there. We're going to try to do a little Q&A at the end of this, depending on how it goes. I'll pick a couple questions in there that I'm able to answer over this webinar. And if not, we'll be able to contact you later. But if everybody could find the chat box and say hello to Dan, who's monitoring that today. And while I'm talking about anything, if there's any questions you have, throw them into there. And Dan might be able to answer you in a couple sentences. And if not, we'll get back to you. So couple people saying hello to Dan in there. So let's talk about what is true position. Commonly, all of us call it true position. Position is tolerancing how far specific features, locations can be from its true position location. Position is the total amount of variation that a dimension can shift from its true position. And there's also material conditions that we'll talk about a little bit later that come into play, that if a pin is larger or a hole is larger, it allows the other mating part to be able to fit into there. So if we look here, and we'll talk about RFS, LMC, MMC today, but we see there's a few things that we're going to have to keep in track of the basic dimensions. But true position is saying from datum A and D and B here, this hole needs to be at a specific location. And the tolerance that you get with that dimensional call out is how much that can shift and move around. So the mating part, say a pin, is going into that hole. It can shift a little bit. That tolerance is the allowance that you have to be able to go into there. And then as we were looking at LMC and MMC, MMC, in short, allows a bonus tolerance if a hole is smaller than nominal or a pin is larger than nominal. Some of these, it's taken more of the function into play. If it's a little looser, if it doesn't need to be a tight fit on there, it's allowing the size of your diameter that you have will add into a bonus tolerance that I'll show you how to do in InSpec. And there's also datum bonuses as well, and we'll show you how to tolerance those. So if you guys joined, I believe it was July, I did a large overview of GD&T, how to measure it, what it is in InSpec. And so you guys might recognize this slide. And you can see that over here in the RFS call out, regardless of feature size, we don't have any of the material condition modifiers on here. You don't see the L with the circle around it or the M with the circle around it. So the RFS, regardless of feature size, says no matter how large or small that diameter is, you don't get any bonus tolerance. It is what it is. And so when we look at this, generally on a blueprint, you'll have the diameter and the tolerance that that diameter has. and then underneath it, you'll have the true position symbol. And next to that will be your tolerance of position. And then next to that are the datums that it's relative to. So in InSpec, if we see that this true position call out is just a B and A or BAD or whatever it might be, we need to make sure that the most recent system or the whatever diameter that we're measuring is referencing those datums that we measured. So when we get into the real examples, I'll show you how it matters, because if you don't have that as your system, those datums set up as your system, your basic dimensions are not going to make sense when you're trying to tolerance it. So we can see that this square over here is a little shifted to the right and down. If we set up the top line and the left line as our datum structure, those basic dimensions would be way off, and then we wouldn't even be able to tolerance it because our true position would be way out. Now over here in the LMC, we see that next to the tolerance for position, we have an L with a circle around it. That's letting us know that when we go to tolerance the true position, we're going to be able to get a little bonus tolerance in there. Same thing, this one is relative to datum A, B, and C on this example. So we need to make sure that we have those datums set up as our system in InSpec. And MMC right here, we got the M with the circle around it. Same thing, if our diameter changes in size, we get a little bonus tolerance there. And if you ever see the M with the circle around it or the L with the circle around it on one of the datums, that means that we'll be able to get even more bonus tolerance out of it in InSpec. So here's one example that we have for a customer. I want to thank them for letting us use this as an example. We have a bunch of basic dimensions going on here. We have a couple true position callouts to different datums. So the first thing that we need to do when we're going to measure true position is find our true position callout. And we can see the modifiers that we're going to have here. We got some material condition added to the tolerance of position, and we have material condition added to one of our datums. So if we're looking at datum A and B, I'll find datum B, which is over here on the left side over here. We see that that diameter is calling out that it's datum B. So depending on the size of this diameter, we're going to be able to get bonus tolerance, and then each one of these 9 diameters here, depending on the size, we might get some bonus tolerance on there too. So we found the datum. Now we got to find any dimensions that influence true position. So in this case, these diameters influence true position. These basic dimensions influence true position, and these basic dimensions for these diameters up here. And you can see that they're all nicely called out to the datum. One thing that you might see on your blueprint is they might give you the distance from datum B to the first diameter, and then they'll give you the distance from the first diameter to the second diameter. So they're stacking those basics across the board. So you might have to do a little math on your end to add all those basics together to get to the last diameter when you're doing any true position on there. So let's get to measuring some actual parts here. I'm going to jump over to InSpec. I got a couple pictures, parts, so you guys can visually see. So we're going to start with an easy one here. This picture right here is, I like to call it this little top hat part. The diameter in the center is our first datum, and then our diameter on the right is our second datum. So we're going to set our origin to the center diameter and skew between the two diameters to get our system set up so our datum structure is correct. And then it calls out true position to 4 holes at each. I always joke and say the corners of the diameter here, but every 90 degrees there's a circle there. So let's jump into InSpec. Clear some of these windows out. All right. Let's go ahead and find our part. One second here. Close out of inspect. Let's go ahead and reopen it. I apologize, my camera is not working right now. Of course, it would happen when I am right in the middle of a webinar. While we're waiting for inspect to open up, and there we go, now the camera's working. There's always technical difficulties when you're trying to show people something, right? This machine that I'm using right now is our demo machine, and we joke around that it's seen 500,000 miles because it's made it around the whole Midwest for years, and it's a great machine and still running well. Kind of shows testament to the durability of these machines. All right, so we got our center hole right here. So I'm going to go ahead and take a diameter measurement. And if I was you, I would maybe clean this part up here a little bit. So I got the 1 diameter for the first datum. And I'll take my second diameter here. This is a real simple example of true position. So I'm going to set my origin to the center diameter, and I'm going to skew between the 2 diameters here. If you guys are part of any of the other webinars that I've done, I talk about simple systems to get your program up and running. This would be one of them. Luckily, it's the same one as the datums. But you're always looking for simple systems like 2 edges of a part to do intersection point, 2 diameters to origin and skew between, just to get things up and running. So I'm going to take my first diameter that I'm going to need to do true position on. Now, usually I recommend taking your first measurement and then renaming it, tolerancing it, and exporting. Since these are all at 90 degrees, rotating about my center diameter, I'm going to go ahead and right-click this diameter here, and I'm going to rotate it real quick just to get all of our measurements. I'm going to do 90 degrees, 3 copies. I'm going to right-click, remeasure. So I got my 4 diameters. So now I'm going to come to my first one, dimension 1. I'm going to hit F3, or you could right-click and open tolerances. So if you're tolerancing diameter, X, Y, centers, because we're going to need those for our true position to calculate. If you change the tolerances in the first window here, it'll transfer over to our true position tolerance boxes. But you also can just jump over to the tolerance tab, and I'm actually going to switch over to millimeters. I'm going to look at my print over here. Our first nominal, so here's our actual, we can't change those. We always joke that if we could change the actual, we would all have perfect parts, and that'd be cheating. But the first nominal that we have on my blueprint is 28.85 in X. That's my first basic. And this one is 0. And you can see deviation from nominal is 4.48, and my tolerance is actually only 0.25. So this true position is out. And I actually know this one is out. If you guys saw the picture of the top hat actually is shifted to the left a little bit. So because of that, or because of that, the way the direction is going, it's actually getting out of tolerance. The part was dropped, or maybe the stock that it was being made from was twisted a little bit. And so we could go around and rename everything. And you can see the true positions are out here. So this is a real simple example of RFS true position. Now I want to go and look at another example of, oh, I don't want to save that. This part right here. So I got this part. Our datum is these two diameters right here. So I'll do the same thing as I did with the top hat. I've set my origin to one diameter and skew in between the two. And you can see real small, there are diameters throughout here that pins to the mating part are going to go through. So all those diameters need to be in certain locations that allow the mating part to connect with it. So I'm going to go ahead and come find my part over here. So here's my first datum, same thing as my top hat. I'm going to take that first diameter and come down and take my other diameter for my two datums. One thing to keep me organized as well is I like naming. If I hit F2, I like renaming my datums so I can keep track of them, especially if we're going to be taking multiple diameters. This bracket here might get real messy and there might be a lot of features that I have to keep track of. So this diameter here, you could see that it's a little misshapen. It's not perfectly a circle here, but this one on this blueprint actually has a MMC call out. So it's actually going to be able to, if we, depending on the size, get us more bonus tolerance. So let's hit F3. So I'm going to jump over to the MMC tab over here. And this basic dimension is 5.15. You could also, when you're going through these tolerance tabs here, you can actually hit tab and it'll move through them. And then I'm going to put my diameter in here. So the difference between the RFS and the material condition tabs is that it actually asks you for the diameter size. So any deviation that we get from the diameter size might come into effect here. So I'm putting in my tolerances here. So you can actually see as soon as I populated my diameter size and my upper and lower tolerances for my diameter, our bonus tolerance pops up over here and it calculates it for you. So we can see over here, if you look down at the points view, that it actually gives you where that true position center is and where the position is here, that it actually shows you that it still fits in. So now we know this certain diameter is going to be able to mate with the other part and be able to fit into there. And that kind of helps us out with the bonus tolerance, that if, you know, this diameter is slightly smaller than it, the mating part probably has the same material condition, and if it all meets together, we're good to go. One thing to keep track of though is up here, you see that you can have the through hole or the pin, like a post. And so whatever feature you're measuring, you need to select that, because you can see that the bonus tolerance actually is affected by what actual type of feature it is. So InSpec has all this in there for you to be able to modify and not have to do all the math yourself on there. Let's go ahead and see if we can find one of these true positions that are out. So we can see that these diameters are actually different sizes here, and they're all different shapes. I actually wonder what this circularity is. Not too terrible. We'll come over here, put in our tolerances. So as long as your blueprint has all the information you need, you should be able to pop all this information in with no difficulties and go there. Some blueprints that you see don't have all the information you need for your basic dimensions, or if you have, depending on if it's Cartesian or polar. That's why I always say, when I showed the picture earlier of got to find the datums, got to find your basic dimensions, anything that influences your features, having all that information before going and measuring is very key. If you don't do that and you just get right to measuring your part, you could waste some time that you're measuring the part, and then you realize I don't have all the basics I need. Then you have to go to engineering or go to your customer or whatever it might be and get that information off of their model, and it's just wasted time. So getting organized before doing anything is so key. So we got some more tolerance, bonus tolerance here, which is nice. This one is out. You could see that it's way out over here. And that means probably the part is bent. So we might want to look into that, or it's just simply out. So if, for example, this datum, like we were showing on our slides over here, let me jump back to it. Too many windows open. So if we go over here to this print here, and we see that the datum has a material condition, so we actually have bonus tolerance added to a datum. If we go back to inspect, how we add that into it is, let's go to this feature, open up our tolerance box. Down here at the bottom, we can set datum bonuses on there. So we can open that up, and this is why I say that renaming the datums is key. So when you do this drop-down menu, if it just said circle 1, 2, and 3, I might not know which one was which. But right here, I'm able to open that up. And so now it asks you to go to your blueprint. It asks you to put in the nominal from the blueprint of your datum. We type in the tolerances. And it's a through hole, and it asks you which material condition you're getting. So we'll click OK. So with that datum bonus that we were given, added more bonus tolerance to it. So this feature is actually in. So looking up here, we're able to report that true position with MMC gets us in tolerance up here. Now, one thing that might be important for you to do is to make sure that when you report to your customer, that if they see this 7 thou number, they might be like, but the tolerance is only 5 thou. But then when you tell them that, oh, we got true position because of the datum, or we got bonus tolerance because of the datum and the diameter that we're measuring, we're actually in tolerance with that. When we export the data, if I come over here and hit F4, when we export the data of true position MMC, in the Excel sheet, it will show you what that bonus tolerance is. Another little trick that you can do is, if you use your calculator function, and I select circle 4, and I click position MMC, and I click bonus, it'll report what your bonus tolerance is on there. So you can give that to your customer and explain why it's still in tolerance, even though this dimension, this actual number up here, is larger than your blueprint on there. So another example that I wanted to show you guys that's a little more complicated is true positioning gaps. Let me see if I have a picture of this for you guys. I do not, I apologize. But I'll explain to you guys what the datums are. So right here, the datum of this part is actually this diameter right here. So we're going to have to get a little creative with our lighting, perhaps. We'll try it out. And then it's asking for true position of this gap, and then the gap next to it on there. So on this blueprint, it actually gives us one basic dimension, and that basic dimension is saying that the center of this gap should be 0 with the center of the diameter here. So the example that I was talking about earlier of getting your program up and running as quick as possible, since this edge right here is not the prettiest edge to just take, get specific datum measurements taken, I'm going to use my profile light. And the first system that I'm going to create off of this part is just a real quick diameter. Let's start a new program. I'm going to take a circle. I'm just going to use 3 quick best edge points. So it's not a real, it's an accurate measurement, but it's not, getting multiple points around that diameter that I would want to use for my datum. If I'm going to measure a datum, I want to take as many points as I can to really make sure that I'm getting the shape of that diameter. So I'm going to take a quick line over here to get my skew. And then get some surface lights, and I'm just going to take a quick focus point on this surface right here. Now, some of you might be saying, Dustin, you're doing it wrong. You should be doing high magnification to get any Z measurements on there, and you're correct. To get my program up and running as quick as possible, I'm going to go ahead and just take a real quick focus point so I don't have to zoom in, refocus, all that stuff. And then I'll go in and I'll take a more accurate magnified point in Z. So I'm going to set my origin of X and Y to the center here. I'm going to set my origin of Z to that focus point, and I'm going to skew to that small line. That might be another thing that you're saying, Dustin, that's not a really good system that you're creating because that line's super small. I know, but I just want to get my program up and running as quick as possible. So now, since I have my first system, everything is going to be automated from here. The first thing I'm going to do is I'm going to do high magnification. I'm going to do a plane focus point. Got one. I'm going to right click in my schematic window because now I have that diameter and I can move around my part a little easier. Now we got our plane. Because this plane is a datum, I want to take at least 4 points around this surface just to really control that and make sure that I'm getting a accurate datum setup. Now I am going to come over and take more accurate and repeatable is key, skew setup here. I'm going to do a line. I'm going to do more inputs. I'm going to do an F-scan line over here. Open that up a little bit. And I'm going to jump to the other side. And now I have that edge, and it's a longer line to skew to. And I'm going to do another line on this side. Jump over. I have more inputs still selected. And now I'm actually going to do line bisect line, and I'm going to click those 2 lines that I just created to get my center line. So I'm going to set origin of X and Y to my diameter. I'm going to set my origin of Z to that plane now, and I'm going to skew to that center line. We still don't have our datum set up yet. But now I have two systems that help the program get up and running, and then a more locked in system that with the plane that I took and the bisect line. So now I'm controlling my program a little bit more. So when I go to take my data measurements, they're more repeatable, and I know I can trust my program. So I'm going to hit the PCS view. So my schematic window is all straightened out. So now, if our datum is this kind of inside diameter right here, let's play around the lighting a little bit to see if we could get a little better lighting than this. See what autofocus does. Let's try lighting coming just from the rear of the machine. Kind of makes that darker circle a little darker, but there's still a little too much gray in there. Let's try from the front. That looks a little bit better. I'm going to bump it up just to see, kind of the same there. Let's try axial light. That might be good there. Let's try using just the outside ring. Kind of seems like most of these lighting options might be the same. And I just use the center ring right there, and I think I like that contrast the best. One thing that we could try is just try segments. You guys might be wondering, well, we're talking a lot about lighting right now. I thought next month's webinar was going to be on lighting. But still, when we're doing true position, we want to make sure that our datums, all of our measurements are spent, you know, using the tools and the lighting to get the most accurate reading. Because if our datum isn't measured correctly, we have no chance with our true position callouts on there. So I like this lighting. I'm going to go ahead and do a circle. I'm going to use more inputs. I'm going to use F-scan arc because I can't see the whole diameter in my camera window. I'm going to make sure that my red arrows here on my tool are going from dark to light. In this case, the reason I'm doing that is because there's less like gray values on the bottom side than the top side. So it's more likely to measure that edge, and you can see all these little blue points that it took when it scanned the edge, that it's a pretty good shape on there. I just want to flip this. It seemed to repeat the kind of the same thing that I had before, but you have a chance of, depending on the window of these points when it's scanning it, to be getting some of those white values or gray values there. So I'm going to do that. I'm going to come down. You guys might know this, but for faster programming, I'm going to right click in my inputs and I'm going to rotate that. Before I do that, I'm going to shrink this arc a little bit. So I'm going to right click on the arc. I'm going to rotate. I'm going to say 90 degrees. 3 copies. I'm going to right click on that circle and remeasure. You guys will notice that my lighting rotates with my measurements there. So now I got my datum set up. So I'm going to set origin of X and Y to that circle, origin of Z to the plane, and I'm going to skew to that center line. So now I have my datums all set up. So now we can come take the measurements that we actually want. So we're already on feature 11, our system 11. We've done 11 measurements, 11 features that we've got, and we haven't even taken the measurement that we need to. But I know that my program and my datum structure is set up to the best it can be, that my measurements, I can know if something's out, I'm positive that it is out. If it's in, I feel confident that it's in. So right here, I actually got pretty good lighting going on right here. There's good contrast right there. So we're going to go ahead and just use this. I'm going to do F-scan line. So now on the blueprint, there's this gap on the right side and there's a gap on the left side. And my blueprint says true position on this gap, and it has the typical call out on it. So that's meaning that I need to take the true position on this side and the other side. So I'm going to do line. And then same thing, my red arrow is going towards where there's there's more contrast and that sharper edge. And here's a good example. You could see in this tool, since my red arrow is coming from the more gray values on the surface of this part, it's actually scanning a bunch of different edges on here, and you can see how crooked in my schematic window, how crooked that line is. So I want to go ahead and flip that scanning tool. And we got a little bit of points still taking on the surface of that part, but since it's the best fit through all those 100 points on there, it's almost averaging those out and not even taking those into account there. And we did talk in last month's webinar of outlier rejection. So if I wanted to, I can take those and kind of do that as an outlier rejection. So now I'm going to click gap since I have my two lines. And then I'm going to open up my tolerance box. And then right here, this is where it gets a little frustrating with true positions like this with gaps, because my X nominal, it doesn't give me that. So I want that's always going to be almost perfect because it's aligned with, or it's not even calling that center of that gap out on there. So a little frustrating part is that when you're programming this, you might have to go in and change this on your program every time, because the center X might deviate a little bit from part to part. But my Y basic is 0. And then my true position is 2 thou, and then we're in tolerance there. So what I would do to go and get the true position of this outside one is I would switch, since I skewed to the center line of this outside gap, I would switch to creating a center line of these gaps to get a skew off of that. So they're a little tricky when you start, true positioning gaps. And my last example that I'm going to go here has an even trickier one on that. So you just got to make sure that your basic dimensions are all set up and your datums are all set up correctly, and you measured them the best of your ability with the best lighting on there. So I have this last part here. It's a little blurry, I apologize, but the center diameter here is a datum. And then the edge up here on the top of the part is another datum that we would skew to. And then I'm going to show you what this inside feature looks like. And it's actually true positioning a gap down here. There's a lot of basic dimensions to this part, some that stack, some that are angles. So this part alone, just setting everything up, would probably be half this webinar. So I promised this customer that we would spend time offline about it, kind of helping her out a little bit. So I'll actually, if it goes really well, I'll record it. And if you guys are really interested in stacking basics and really difficult dimensions, if they're okay with it, I will record that and send it out to anybody who is interested on that. But let's go ahead and take a look at what that feature actually looks like. I did a section view of it. Over here. So when I sectioned this part, it got really messy. And sometimes you're not able to section your parts to get the dimension that you need. So on this part, actually, it might be better, since it's an internal feature, to use touch probe or explore other options on that. So the one thing that I did when I first took a look at this part, I was kind of just playing around with it. I was trying to figure out a way to be able to get the gap that it calls out, which is basically this sharp corner and this sharp corner, which you can kind of see that those sharp corners don't exist because of the way that I sectioned it. But one thing that I was playing around with is I took this edge here and I took this edge here, and then the bottom edge. And now we kind of have like a cup shape here. And now doing intersection points between these lines. This is where I'm using this example just to explain to you guys how getting creative with your construction icons and your dimensions will help you out. If you're looking at a feature that you're like, I have no idea how to measure that, don't forget about the construction icons. of making that gap that we need, because there's no gap that exists here or here because we got the angled lines here. So one thing that I was playing around with, and I gotta talk to the customer a little bit more about this part, but this might not be the right way to do it. But if I did line perpendicular construction icon, and I click that line through that center of point, that sharp corner, and I did the same thing on the other side, now I got a gap of those two sharp corners that I'm able to true position on there once I have my datums set up on there. So I want to show that quick example of exploring construction icons to get the true position callouts that you're being asked for. So just keep those in mind. A lot of people, since you're not always clicking the construction icons, kind of forget about tools that you have in your toolbox. So remember those when you're getting your measurements. If you guys have any problem parts like this, when I say problem parts, I mean problem parts to you not sure how to measure them, feel free to contact me and Dan, and we'd be able to help you out. Take a look at the blueprint, talk through it, see what it's actually asking for. You might be missing some basic dimensions, or you're not using the right datum setup, something like that. We're here to help you guys. The last thing that I wanted to show you before wrapping up today, and go ahead and jump to the slide, is there are some parts that we showed that there are a lot of true positions on multiple sides. Today's examples, luckily we could see all the dimensions except the one that I had a section. If there's any features that are on, the left side of the part, right side of the part, I just wanted to show you guys this cool tool that we have. On the MicroView, you can add on a rotary. So if you have a part that looks really crazy like this, with features on all sides, instead of writing a program that you have to flip the part 2-3 times, I wanted you guys to be aware, if you didn't know, that there is a rotary option. So this part right here, we'll watch this video. I actually used the rotary, and you'll see me taking the measurements on this part, and then I took another video of the rotary measuring the part. So that first part that I did, I auto leveled to datum A, that top plane, so I know that my measurements are flat parallel with the camera. So now I went and I'm taking a more detailed version of my datum. So when I start doing true position, which was that little notch right there, and now this video is it moving around the machine, getting those measurements on there. And then right there, there's a threaded hole on the side and that radius there that I needed to get. And so I'm able to, in one program, flip the part multiple times and get all of my measurements that I need on there. And the last true position that I had that I needed to get was the center of this sphere. You could kind of see that curved surface on that part. It actually called out the center of that sphere on that part. So I'm able to, in one program, instead of flipping my part a bunch of times, I'm able to chuck it in the rotary, take all my measurements, and report it as needed. And this program probably would have taken me 10 minutes to run because I had to flip it multiple times. But since I had the rotary, we were able to knock it all out in one shot. So just a cool little accessory. Not a lot of customers know about it. If it's been a while since you bought your machine, if this is something that interests you, learning more about, let me know. Get you in contact with one of the sales team. They could talk you through the options, and we'll look at your parts, see if it's a good fit for the rotary, and if it'd be a good option for you. So I just want to kind of throw that in there so you guys are aware of it. So just kind of review as we're wrapping up here. Remember to look at what your true position is calling out, in material conditions that modify it, and look for your basic dimensions. You need all that to be able to report and measure your true position on there. I included these slides as well. If you remember from the last webinar that we did 2 webinars ago about GD&T. I wanted to include these because I can send you this PDF slideshow of all this information, and it's a step-by-step exercise to measuring true position, and you can apply these step-by-steps to your parts on there. So one with LMC and one with MMC. One of the last things that I wanted to talk about here is exporting true position. When we export true position, this option down here, when we go to our exporting tab, is I like to do tab new line, because you can see here that's circle dimension 15. We have center X, center Y, which we need to report for true position, and we have our diameter, and we have our true position readout all in one column here. The other option up here is tab new line, has it all going in one row, which I kind of find hard to find where my nominals are when I'm going down this row. I like having it all in one column to have it all lined up when I do my report. If you currently aren't reporting your basic dimensions when you do true position, I recommend starting to. If you have a true position that's out and you don't report your XY location, nobody knows how to fix that true position. All the true position tells you is that it's out or in, but if you don't have the basic dimensions, you don't know how to fix your tool, fix your mold, whatever it might be, to bring those basic dimensions, those actual on the part, back into spec to get your true position on there. I saw that we had a lot of Wisconsin or Indiana customers registered today. If you guys are interested in more training, we're setting up a training webinar in Warsaw, Indiana, where our sales rep Adam is from. And if you're interested, contact me and mention this webinar to get 10% off your seats. It's going to be good. It's basic and advanced training. It's good for customers that have new operators or operators that haven't gone through training in a long time. They might know a lot of stuff and it might be review, but it's always good to hear from other customers that are in the room, their challenges, their hurdles that they're going on. And so a lot of good conversation comes out of these training seminars, because you have manufacturers from plastic to medical to cast parts, anything like that. So it's good to hear and you bounce ideas off of each other. And I just wanted to throw this out there too. If you're interested in having a training seminar come to a city near you, let me know, and I'll see what kind of requests there are and see if we can come to a city closer to you. But I want to thank everybody for joining another monthly webinar. Next month, we will be talking about lighting tips and tricks. There are a lot of difficult materials like clear plastics, really reflective parts. So I want to tackle that because I get a lot of questions of what's the perfect lighting for this feature. If you guys have a difficult part that you're not finding the right lighting for that, I'd love to use an example in the next webinar, because you guys are requesting more and more that I use actual parts so we can get away from the sample slide. And I love that, because the sample slide isn't the best example for the amount of different parts that you guys are measuring every day. So we have a few minutes here left. If you guys have any questions, pop them into the chat box and I'll try to answer anything that I can here, or we'll contact you afterwards to knock those questions out. And also after this webinar, I'm going to be sending you guys an email with a link to a survey that you guys have been sending me great feedback of things that you want to hear about, topics that you want to cover, and challenging dimensions. So it's going to make it just like the training seminars that I do in different cities. Is it gets that conversation going, and it might not be something that somebody else is thinking about, but it gets their mind going, and then everybody can measure better. Because that's our job, is to measure these parts, make sure they're good, catching the ones that are bad. So we're generating great products for manufacturing out there. So if anybody has any questions, pop them in the chat box. We'll try to answer those here. If not, feel free to send me or Dan an email. And thank you again for joining this month's webinar. So one question I see here is 4 points for an angle, where to place for good readings. For not having exact good reference on the part or knowing what's going on with that actual dimension, one thing that I will say with angles is let's use, I'm going to go up here to a feature up here. So there's a lot of angles going on over here. I'm going to switch my lighting. And if this doesn't answer your question, email Dustin at atiquality.com and Dan at atiquality.com if you can provide a print and with your with a specific angle dimension. We'd love to help you out with that. So one thing that I want to make sure when I'm doing angles is when I take the edge, I'm staying a little away from where that radius starts and bring in the longest line I can to where the other radius starts. And since this is a smaller feature, I actually want to zoom in a little bit because I don't like how small of an F-scan line that is. And I know that I'm a little away from that radius and there. So I'm taking that whole edge as much as I can before taking my angle measurement. And I'll always measure the lines first and then click angle in those two lines to get that dimension right there. And 120, I'd have to look at the blueprint, but it looks like it's that's a pretty solid number, 120 right there. If you were just using points, so if I do line, best edge point, and best edge point, one thing to make sure is that you stay away from that radius where it starts to curve right there. And you can see the best edge, it scans that edge, that blue line, and that pink crosshair right there is where it's actually putting the point on there. And same thing, I'll do line, best edge point, make sure I'm away from that radius. Take the whole length of the line, I'm away from that radius. And let's go ahead and take that angle measurement. And that one actually, if it is 120, got us closer to nominal. But I would be a little leery that since I'm not getting any of the edge in the middle, that it might not be the best technique for that. And we might be reporting a good number, or we might be reporting a bad number on there. Cool, so perfect example. You're welcome. That was a good question. Any other questions from anybody? Awesome. Thanks for those who are still with us. Go ahead and in the survey that I'll send you out, if you have any questions, send that to us and we can answer you. And I really appreciate the feedback. So thank you for everybody joining today.